The top of this note sheet that you have are definitions that you will see on the test. Okay, it'll be matching section. We start with pre-image. So we talked about this just a minute ago, but a pre-image is the original figure, okay, before the transformation, before you do anything to it. We call that the pre-image. Okay? The image is the figure that happens after you've changed or moved the figure. So right now we've talked about translations and we've talked about reflections. Next class we'll talk about what happens when we rotate figures. A transformation, okay, like I said, there are 3 types of transformations. That's what this whole chapter is about. It maps a pre-image to an image. Basically, it's something that takes one image and moves it to another image. There are 3 types of transformations. They are reflections, rotations, and translations. Okay? There are 3 ways we can move a 2-dimensional figure to another spot in the coordinate plane that we're going to talk about right now. Those are all 3 called transformations. And then a translation, that was the first one we talked about, is it's a type of transformation, and this says that moves all points of a figure the same distance in the same direction. Okay? We've either moved it to the right 5 and up 2, we moved it to the left 1 and down 6, we moved it to the left 1 and up 4, something like that. We translated it. We just shifted it. That's the first type of transformation that we talked about. So reflection is just a type of transformation that flips a figure. I'm going to give you a line of reflection. You can't just flip a figure randomly. You have to flip it over something, right? You have to flip it over some line. And we're going to talk about 4 different ones that we're going to reflect over. An isometry, okay, is something that you do to a figure where the figure doesn't change. It stays congruent. So both a reflection and a translation are isometries because it preserves these things. Meaning if points A and B were 5 units apart, after you flip it, they're still 5 units apart. If the angle of a triangle was 60 degrees, after you translate it, it's still 60 degrees, right? Betweenness of points. If point B was between points A and C, after you flip it, it's still between points A and C. And collinearity, if 3 points were collinear, after you translate it, they're still collinear. So isometry means whatever you did to the figure, it preserved these things. Those things did not change. You just shifted the figure. So when a reflection and a translation are both isometries. Okay? They don't change the figure at all. They just moved it. It preserved all these things. None of these changed. The first one says graph DE. So this is a segment with endpoints at -3, -4. Again, I'm going to label my coordinates. So there's D. And E is at 4, 2. And I'm going to just connect those because I'm talking about a segment here. Again, that's at 4, 2. This is at -3, -4. And it wants you to translate it 1 unit to the right and 3 units up. So, since I have the graph here, I can go 1 unit to the right and 3 units up. And this point is going to be called what then? What do we say that after we've translated the image? D prime, right? You have to put the apostrophe on it. So that shows me this is the image, this is the pre-image. That's D prime. That's at the coordinates of that. Since I went 1 unit to the right, that's at -2. Since I went 3 units up, that's at -1. Same thing here. I go 1 unit to the right, 3 units up. This will be E prime. And that's at 5, 5. I connect that, and there's my translation. I just shifted this figure, right? It's still the same distance from D to E and D prime to E prime. I didn't change it. Okay, I just shifted it. I translated it. So this is what I want you to do when you translate things. I want you to write the new coordinates. You can write them off to the side if you want. You don't have to write them on the graph if you don't want. But you do need to write the new coordinates. If for some reason your line got a lot longer or a lot shorter, you know you probably counted wrong somewhere or you added or subtracted wrong because this still should say the same distance. It's an isometry. All right, let's go to example 2. This is how you'll most often see it on example 2 here. It says graph triangle XYZ, so I'm going to connect these points. X is at 3, -4. That's at 3, negative 4. Y is at negative 1, 5. That's Y is at negative 1, 5. And Z is at 1, 2. So this is going to be kind of a really squished together triangle. So we connect these. Going to look something like that. Oops. Go back. That's my pre-image, right? That's my image before I do anything to it. Now, the problem says take it x minus 3, x plus 2. So are we going to go to the left or are we going to go to the right? We're going to go to the left because it says subtract 3 from the x coordinate. X is the horizontal. Minus means we go to the left. So I'm going to take each of these x coordinates and go 3 to the left. Y coordinate plus 2 means I'm going to go up 2, right? So let's do that for each of these. 3 to the left, up 2. So this is now x prime. And the coordinates of that are going to be 0, negative 2. I went 3 to the left, so I subtracted 3. I went 2 up, so I added 2. Okay? That is now x prime. You need to put the apostrophe on it to denote that's the image. Z, 3 to the left, 1, 2, 3, up 2. There is Z prime is at negative 2, 4. I went 3 to the left, so I subtracted 3 from that coordinate. I went 2 up, so I added 2 to that coordinate. And the y coordinate, 3 to the left, up 2. That's y prime, and that's coordinates are negative 4, 7. I went 3 to the left, so I subtracted 3. I went 2 up, so I added 2. Connect those points. Oops, I didn't connect that. It looks like that. There, there, and there. Again, my triangle, I know I didn't use a straight edge, so it's not exact, but it should still look the same. It shouldn't have got longer or shorter anywhere. It should still have the same angle measures. It's an isometry. I just shifted it 3 to the left and 2 up. And I labeled the coordinates with x prime, y prime, and z prime. Back page here is reflections. So we talked about these rules. Okay, let me put a graph over here off to the side. The top part, I want you to write the rules for these reflections, and we talked about a couple of them already. So I'm going to draw a little graph here off to the side. The first rule is what happens to the coordinates of the x-axis. Okay, so I like to write my rules with AB as the coordinates. The reason I do that is that way I don't get mixed up with x comes first, y comes first, if I have to flip them, that sort of thing. So if my coordinates are AB, when I flip over the x-axis, what do we say happens to the coordinates? Remember? Yeah, Jared? Yeah, the y becomes negative. So they're now going to become A negative B, or A opposite B. If the B was negative, it then becomes positive. But that's my rule for the x-axis, right? We then talked about the rule for the y-axis. And it says if you have the coordinates A, B, what happened to the coordinates when you reflect over the y-axis? Yeah, the x became negative. So they became opposite x, B. Okay. We have two more here. We have the line y equals x, and we have the origin. Then we have two more rules. Now, looking at my graph, the line y equals x, that's the line like this. Okay? It's the line that goes through 0, 0, 1, 1, 2, 2. That one isn't really a good representation of it. It looks like kind of that. Goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, y equals x, right? So if I have a figure, let's just say I draw some figure like this, and I flip it over that line, it's going to look something like this, right? Everybody with me? If this was my pre-image and I flipped it over that line, it's going to look like that, right? This is the line y equals x. This is the rule that happens to those coordinates, okay? Instead of being AB, instead of the original coordinates, they just become switched. If the coordinates of this were 1, 2, the new coordinates are now 2, 1. They just switch. Okay? That's the rule for the line y equals x. The coordinates just switch. For example, if I look here, if I made this coordinate, let's do this. Let's say I took this triangle and I flipped it. Okay. This coordinate is at -1, +1. It's then going to become +1, -1. This coordinate is at -1, 3. It's then going to become 3, -1. And this one's at -2, 1. It's going to become 1, -2. So it would look like that, right? That's what happens after I flipped it over this line, this diagonal line, y equals x. This is my line of reflection. And then the last one we have is the origin. Now, the origin is just a point, right? And we need a line of reflection. What the origin stands for is if you have a figure, the origin means you flip it over both the x-axis and the y-axis. It doesn't matter the order because it ends up in the same spot every time. So the origin means like you flip it over here and then you flip it down here. Or you flip it over the x-axis first, then the y-axis. Okay? The origin means your two lines of reflections are the y-axis and the x-axis. You actually flip it twice. You reflect it twice. The rule for the origin is if you have the coordinates A, B, they then become the coordinates opposite A, opposite B. They both become their opposites. So if the coordinates were at 2, 3, the new coordinates are at -2, -3. If the coordinates were at -3, -4, the coordinates are then at 3, 4. They both become their opposites. So these are the rules you need to know for reflections. Okay? These are going to be your 4 lines of reflections that I'll ask you to reflect over. There's the first one, and it says it wants your line of reflection to be the x-axis. So I want to flip it over that line. So you know you're going to take it and it's going to end up down here somewhere. Okay? But you want to look at the rule of what happens with the coordinates. Now, it's not going left or right at all. So the x coordinates are going to stay the same. The rule is the y coordinates become their opposites. So if this is my pre-image, B is going to end up at -3, -3. Right? That's going to be B prime. A prime is going to end up at 6, -8 is going to be A prime. I'm out of room on my graph, so I'm just going to write the coordinates. And C is going to be at -6, -9 is going to be C prime. And then I would connect those points and make that triangle reflected over the x-axis. Again, you need to have the coordinates. If you want to put the coordinates off to the side, you can. You can put them like off the edge of the graph. But I want to see the coordinates of the new graph also, in addition to the figure. Here's my pre-image, and it wants you to flip over the line y equals x. That's this line. Okay? That's this diagonal line that goes through 1, 1, 2, 2, 3, 3. So it's going to end up somewhere down here.
Can we just make that ourselves? Like, we just put lines right in the middle?
So that's my pre-image. The rule is the coordinates just exchange places. So B prime is going to be at 4, -4. A prime is going to be at 10, 2. And C prime is going to be at 8, -5. I'm out of room, so I'm not going to draw it. But those would be your coordinates, right? The rule for the line y equals x is they just flip spots. The x become the y's, the y become the x. So these should be your new coordinates you want to have down. Here's the next one, quadrilateral RSTU. It says reflect over the line, over the y-axis. So I'm going to reflect over that line. Okay, so I'm just going to flip it over that line. So it's going to actually lie on top of each other, the pre-image and the image, because it's already on the y-axis. So I'm just kind of flipping it over this axis. That's okay. Again, the coordinates of each of these were at 3, 2, 2, -1, -1, -3, and -2, 1. The rule for the y-axis, since it doesn't shift up or down, the y-coordinate stays the same, the x-coordinate just becomes its opposite. So u prime is going to be at -3, 2. That's u prime, -3, 2. T prime is going to be at 2, 1. R prime is going to be at -2, -1. And S prime is going to be at 1, -3. So it's going to look like that. Again, the figure isn't getting any larger or smaller. I just flipped it over that axis. Okay? I took it, picked it up, flipped it, folded it over that line, and that's what it would look like. R prime, S prime, T prime, and U prime. The coordinates here, 1, -3, -2, -1, 2, 1, and -3, 2. This says reflect over the origin. So it's like you're flipping it over the x-axis and you're flipping it over the y-axis 2 separate times. It doesn't matter which one comes first. So you kind of flip it over once, then flip it up, right? So the rule for the origin is both the coordinates just become their opposites. So U prime, if U was at 2, 4, if the pre-image, U prime is going to be at -2, -4. There's U prime. T prime both becomes its opposite. It's going to be at 2, -1. So T prime is actually going to lay on top of where R was. R prime is going to be at -2, +1. So R prime is going to lay on top of there. And S prime is going to be at 3, 5. My figure would look like that.